Applications of trigonometric ratios. Most of the time, trigonometric ratios are used to solve real-world problems, as you saw at the beginning of this unit. Now that you're familiar with the derivation of the three trigonometric ratios, sine, cosine, and tangent, you are ready to apply your knowledge and practice solving these problems. Before we begin, let's review some key vocabulary that you will see in these word problems. Applications of trigonometric ratios. The angle of elevation here is the angle above the horizontal to an object, and the angle of depression is the angle below the horizontal to an object, here. The angle of elevation and the angle of depression are both measured relative to parallel horizontal lines, so they're equal in measure. So here we have the angle of depression equal to the angle of elevation. They're both 20 degrees because if these lines are parallel here, then this is the transversal that cuts through them, and so these are alternate interior angles. Note, this model imagines that the Earth is flat. Here's an example. Amy is flying a kite at an angle of 58 degrees. The kite string is 158 feet long, and Amy's arm is 3 feet off the ground. How high is the kite off the ground? So that would be actually this distance here would be the distance, how high the kite is off the ground. Alright, so we have our diagram here. So we're trying to find x, and we have the hypotenuse and we have the angle. So using SOHCAHTOA, we see that sine is opposite over hypotenuse. We want to use sine here. So sine theta equals x over 158. Sine 58 degrees is 0.8480. And we solve for x, and then we add in this 3 feet here for Amy's arm height, and we get that the kite is about 137 feet off the ground. Here's another example. You are standing on a mountain that is 5,306 feet high. You look down at your campsite at an angle of 30 degrees. If you are 6 feet tall, how far is the base of the mountain from the campsite? So here's our little diagram that shows that this is how tall the mountain is, plus 6 feet for your height. We have the angle of depression here at 30 degrees, and we have the distance to the campsite as x. So if we take away the pictures, we're left with just this diagram. So it's the mountain height plus 6 gives us 5,312 here. We have this angle, 30 degrees, and if we want opposite over adjacent, that's tan. SOHCAHTOA, so TOA is the end portion, tan is opposite over adjacent. So we have tan 30 equals 0.5774 equals 5,312 over x. Solve for x, and we get that the campsite is about 9,200 feet from the base of the mountain. Applications of inverse trigonometric values. As we discussed earlier in this unit, trigonometric ratios and the inverse trigonometric values are used to solve real-world problems. Now that you're familiar with the three inverse trigonometric values, inverse sine, inverse cosine, inverse tangent, you are ready to apply your knowledge and practice solving these problems. Ronaldo is 26 meters from the goal line. He shoots the ball forcefully at the goal. The height of the goal is 2.4 meters. What is the maximum angle of elevation at which Ronaldo can kick the ball and still score a goal? Alright, so this is the angle here. The information we've been given is the opposite side and the adjacent side. So that would be tangent. So tangent of theta is 2.4 over 26. Then we have theta equals the inverse tangent of 2.4 over 26. Therefore, theta equals 5.3 degrees. The angle of elevation at which Ronaldo can kick the ball and still make a goal is a maximum of 5.3 degrees. You lean a 20-foot ladder up against a wall. The base of the ladder is 5 feet from the edge of the wall. What is the angle of elevation created by the ladder and the ground? Alright, so here's our angle here, theta, and the information we have is adjacent and hypotenuse. So the trigonometric function we want is cosine, because cosine is adjacent over hypotenuse. Therefore, cosine theta equals 5 over 20. Theta equals the inverse cosine of 5 over 20. Theta is about 75.52 degrees.